today's lesson, we're going to talk about something called the remainder theorem. And the remainder theorem basically says if I have a function f of x and it's divided by x minus k, which is our divisor, then the meaning of the remainder would just be simply whatever k is, f of k, that's going to equal our remainder. All right, and that's where we did like when we saw the substitution method yesterday, the direct substitution, and you could solve for the remainder that way. Another way to put this is to say f of x is going to equal our quotient of x plus the remainder over our divisor. There we go, x minus k. All right, so which is something we've written down before. And then we have the issue of what happens if the remainder is actually 0. So we've talked about this a little bit yesterday, and this is where we're going to get a little more in depth about it now. So we were saying the quotient of x is 0 over our divisor, x minus k. Then that means that our answer is simply just the quotient. And that means that this is where the factor theorem comes in. If we have a remainder of 0, we've used this term already, that means we found a factor. Okay?
When you're writing the equation, does x minus k have to be in parentheses?
No, it doesn't.
Okay.
So good question. Does not have to be in parentheses there. Okay, so when I say a polynomial has a factor, all right, that means the remainder must equal 0. All right, so if I give you a factor and I say, hey, this term is a factor, that means the remainder has to equal 0. Okay? And what we're going to be working on today is we're going to look at polynomials in standard form, and then we want to try and rewrite them into factored form for purposes of being able to find all of the possible x-intercepts. All right, so factored form polynomials, like we're used to seeing them, So for example, a quadratic would be like f of x equals x plus 1 times x plus 2. I'm just making these numbers up right now. That's factored form. And one thing I want to point out about factored form, degree 2 of a quadratic, factored form should have 2 x's. And remember, in standard form, it would be written as like ax squared plus bx plus c. So you'd see the x squared, that's how you'd know it's a degree 2. A cubic function, in standard form, you'd see it as a x cubed plus or minus a bunch of other stuff. In factored form, it's going to look like x plus 1 times x plus 2 times x plus 3. I'm just, again, making these numbers up right now. It doesn't matter. But what we see in factored form, we'll see 3 x's in 3 different sets of parentheses. That's how we know it's a factored form cubic function. And then for quartic, degree 4, we're going to follow a similar pattern. And this one we could say f of x equals 2x minus 3. I'm just making numbers up, but I'm going to write down what I consider a factored form. The key, though, is when it's a quartic function, we should see 1, 2, 3, 4 sets of parentheses with 4 separate x's when it's in factored form. The degrees of all the polynomials should add up to 4 when all the factors are being multiplied together. Okay, that's what factored form looks like for quadratic functions. Okay. Now, a couple different things that we're going to see here is we're going to see a couple different uses of vocabulary, so different terminology. So, for example, you might see, like for problem 1 down below us, we're going to say, given one factor of a polynomial, find the other factors. All right, so that's one way we could say, hey, we're looking for simplifying this expression. Another vocabulary word we're going to see that we just saw it in the warm-up, and we used it on a worksheet a couple of classes ago. Given one 0, find the other zeros. And then finally, given one solution, find the other solutions. And they all have very similar words, but they're written ever so slightly differently. So for example, let's show you what I mean. Let's say a factor, for example. A factor is going to be written like that. That's a factor. X minus 4, that quantity. If I wanted to find the 0, I would take that x minus 4 equals 0. I'd add 4 to both sides, and I'd get x equals 4. That's the 0. So it looks slightly different than a factor. Okay? And then the final one, given a solution, that'd be f of 4 equals 0. That's what a solution looks like. Okay? F of 4 equals 0. So that's the 3 terms that we're going to see here. Okay? So just to recap, the way we might see things written down, we might see something like, I'm just going to use different numbers now. 1 comma 0. That's an example of an x-intercept. And then if I wrote it as x minus 1, that's an example of a factor. X equals 1, that's a 0. And then finally, f of 1 equals 0, that's a solution. Okay? But all of those terms mean something very, very similar. They're just slightly different the way we would express them. And you don't need to memorize each one, but you just need to have this written down in your notes. So if I ask you, hey, find the zeros, you know how to write your answers as zeros. Or if you say find the solution, you know how to do that. Okay, so you know how to find those solutions. That's the key with these particular problems. Okay, so example 1 here says factor 2x cubed plus x squared minus 41x plus 20. This is a degree 3 polynomial. I want to take a little mental note of that. Okay? And that means when it's in factored form, I want it to look like this up here. It's going to have 3 separate sets of parentheses with 3 individual x's. That's factored form. All right. In this example, we're going to use long division to break down the cubic. Then we're going to factor the resulting quadratic before finally comparing our results to the x-intercepts of the graph. So we're going to start with long division. I have 2x cubed plus x squared minus 41x plus 20. I'm doing long division on this problem because I have this 2x minus 1. And remember we talked about how synthetic division kind of fails when we have a number being multiplied by the x, it gets a little tougher to successfully pull off synthetic division. So that's why we're looking at doing it with long division for this particular problem. So I need to ignore the 1, that's our remainder, and I need to multiply 2x times something to get to 2x cubed. And I actually already wrote x squared up there. So I can take this x squared and multiply it by 2x, and I get 2x cubed. And then I take x squared and I multiply it by -1, and I get the second part of the expression, which is -1x squared. And then it's a polynomial subtraction problem, and I have to distribute that negative through. It's going to become a -2x squared plus, or -2x cubed plus x squared. So I end up getting the 2x cubes cancel out, and I get 2x squareds, and then I pull down the 41x. And then I have to ask myself, 2x times what equals 2x squared? That's going to be a positive x. X times 2x equals 2x squared. X times -1 equals -x. Then I'm going to distribute the negative again. That's going to become a positive x there. And I end up getting -40x. That drops down. Drop my plus 20 down as well. 2 times what equals -40x? In this case, it's going to be -20. -20 times 2 is -40x. -20 times +1 is +20. Now when I distribute the negative, I get a +40x and a -20. And that gives me 0, remainder 0, which is perfect. So what I just did was I just took the expression in standard form, 2x cubed plus x squared minus 41x plus 20. I found a divisor that works, and I divided 2x plus 1, or 2x minus 1, and now I've got a new quotient, x squared plus x minus 20. If I multiplied that by 2x minus 1, I would be back in factored form. So this quotient right here, or I'd be back in standard form, I'm sorry. If I multiplied x squared plus x minus 20 times 2x minus 1, I'd be back in standard form. So that quotient is getting us one step closer to factored form. Now what we just practiced on the warm-up was we were going to take a problem like this, and we want to factor this. Once it's in quadratic forms, we should be very good at factoring from our AGS3 skills from last year. And that's what we started on the warm-up. Now we need to factor this. So I want something that has a difference of 1 in the middle, but multiplies to get me -20. So I'm going to need a positive and a negative. Difference of 1 that multiplies to 20 has got to be 5 and 4. The bigger number has to be positive because I want a positive 1 in the middle. And sure enough, I get -4x and positive 5x. That works. So x plus 5 and x minus 4 is the same as x squared plus x minus 20. So now I can say my factored form then is going to be 2x minus 1 times x plus 5 times x plus 4. Now I've got 3 x's. In standard form, I had a x to the third. So I have found my factored form polynomial. All because I got it down to a quadratic, and then I have methods for factoring quadratics already. So that's kind of what we're working towards now. Okay. Just a reminder, whenever you see the word is a factor, that means we have a remainder of 0. And that's exactly what we saw when we solved it. If I solve this with long division and I get a remainder that's not 0, that means I did something wrong, because I'm telling you at the very beginning of the problem, this is definitely a factor. it's going to have a remainder of 0. So it's important that you take note of that. All right. So the goal today, what we're going to be working on is we're going to try and rewrite things that are from standard form, like this, and we're going to try and get them to this factored form. Because now I can see the 3 x-intercepts. One of them is going to be at positive 1/2, one's going to be at negative 5, one's going to be at positive 4. And if I graphed it, I should be able to see those x-intercepts at 1. We might see another term like this where it says 1, 0 is this. What are the other zeros? So when it says 0 and it's already written as x equals -2, remember we had to do that yesterday. We had to put it in that form in order to do synthetic division. So we can actually start with synthetic division on this one since it's already in that form for us. And it's x cubed plus 2x squared minus 9x minus 18. It's a third degree, so there should be 4 terms, and there are. 1, 2, -9, -18. And then I can just go ahead and run my synthetic division really quickly. There's a 0. -2 times 0 is 0. I get a -9. -9 times 0 is 18. And I get a remainder 0, which is perfect. So what happens in this problem, f of x equals x cubed plus 2x squared minus 9x minus 18. That's going to be the same as if I write this as x squared plus 0x minus 9. But then I also want to take this part, which was x equals -2, and I want to turn that back into a factor so I can write it down in factor form. X plus 2. So if I multiplied x squared minus 9 times x plus 2, I would get back to what I started with in standard form. Now the x squared minus 9, that's actually not too bad because I can rewrite that as x plus square root of 9, x minus square root of 9 because it's a difference of squares problem. And x plus square root of 9 is x plus 3, x minus square root of 9 is x minus 3. So that's not too bad. But this problem doesn't ask me to find the factors. This problem asks me to find the zeros. So if I want to find the zeros, my answers need to be as x equals. I know one of them is -2 because that was given at the beginning. The other ones would be if I took like x plus 3 equals 0 and I subtracted 3 from both sides, I got x equals -3. X minus 3 equals 0 and I added 3 to both sides and I got x equals 3. So my zeros would be -2, -3, positive 3. That's how I'd write down my zeros. Okay. So that's the difference in vocabulary. We just have to make sure we understand how the vocabulary works. Okay. All right, final example here today, and then I'll let you guys practice some. This one says find all of the zeros of f of x equals 2x cubed minus 5x squared minus 4x plus 7. Notice that I'm not given a 0. Since I'm not given a 0 to start, what I need to do is I need to graph this and find the zeros. Which is never a bad idea anyway. Because if I find all the zeros on the graph first, then I can prove that I'm doing my problem correctly. So I want to go to Desmos and graph this equation. I'm going to switch screens here. I just saw my zeros, so I'm going to write them down now. X equals -1.2661 and 2.766. Now, which one's probably going to be the easiest one to use there when I'm trying to do synthetic division? Probably the 1. So that's the one I'm going to want to use when I'm doing the synthetic division here. It's a third degree polynomial, so it should have 4 terms, and it does. And then we get 1 times -3 is -3. 1 times -7 is -7. And I get a 0, which is perfect. So what happens now is I've got my factored form, x equals 1. That's the same as if I subtracted 1 from both sides, and my factor would be x minus 1. And then the other remaining part is 2x squared minus 3x minus 7. I've divided one term out. Because I have some really weird zeros here, I know that I'm not going to be able to use the simple factoring method to find those. I know I'm not going to be able to complete the square easily to find those. What I'm going to need to do here is I'm going to need to actually use the quadratic formula. And the quadratic formula, we might remember, x equals -b plus or minus b squared minus 4ac over 2a. So in this particular problem, I want to find the exact x-intercepts, or the exact zeros, not the approximations of -1.266 and 2.766. So I need to use the quadratic formula in order to do that. Remember, the b value is going to be, the b value is going to be the -3. The a value is going to be the +2. And the c value is then -7. So I can plug those values in now. X equals negative times -3 times -3 squared minus 4 times 2 times -7 over 2 times 2. Four times 7 is 28, times 2 is 56, all over 4. So what I'll end up getting is a weird number here. X equals 3 plus or minus square root of 65. And it turns out if I were to put that into my calculator, like 3 minus square root of 65 divided by 4, I would get -1.266. And if I put 3 plus square root of 65 divided by 4 in my calculator, I'd get 2.766. So I can verify those on the graph, but I still need to show my work algebraically to find the exact zero. That's the tricky part for these ones. So my 3 zeros end up being 3 minus square root of 65 over 4, 1, and 3 plus square root of 65 over 4. Those would be the exact zeros. So that part can be a little bit tricky because we're going back to this quadratic formula that we used last year. But don't worry, you don't need to memorize the quadratic formula, but you do need to know how to apply it and how to plug the numbers in. All right, that's the tricky part for these types of problems. Okay, but that's only if you're looking at the graph and you see really weird numbers. That's when you know you need to use the quadratic formula. Otherwise, you could always use the box method to factor and simplify. Okay, so now there's 3 practice problems, or actually 4 practice problems I want you guys to give a try. All right, so try those out now, and we're trying to rewrite things in factored form, find the zeros, okay? So give those problems a try. Let me know if you have any questions at all, and we can look over it together. So 1, 2, and 3 written down. I've got number 1, remember, written in factored form because that's what it asks for. Problems 2 and 3 ask for the zeros, so I've got the zeros boxed up in those 2. If you have questions on any of those 3, please let me know. But hopefully we can use division to simplify the first part, and then the second part is going to be factoring. All right, that's kind of the key to be successful in these types of problems. And there's a lot of steps at this point, so I just want to make sure you're following through with each step.
On number 2, in the box you wrote positive 5x and negative 2x, but in the answer you wrote negative 5 and positive 2.
Sure.
Is there a reason that it changes?
Yeah, so What happens on number 2, we end up putting like x plus 5 and x minus 2. So think if you have x plus 5 equals 0, that's the factor, but if you subtract 5 from each side, then the 0 is actually a negative 5.
Oh, that's right. All right, thank you.
Okay, yeah, no problem. So yeah, the zeros and the factors are always like opposite signs. It looks kind of weird. All right, the last one, a box has a volume given by this formula, 2x cubed plus 17x squared plus 46x plus 40. It has a height of x plus 2 and a length of x plus 4. Let's find the depth. So what that means is I know that I have 4 terms here, and I want to factor this. And if I know the height is x plus 2, I can subtract 2 from both sides, and I get x equals negative 2. That's the number I can use up front here. I get a negative 4, gives me a 13, gives me a negative 26, which gives me a 20, a negative 40, and a 0. So sure enough, the height checks out. It's got a remainder of 0. And then the second part says I have a length of x plus 4. Technically, I could try and factor this problem, or what I could do, because I really like this synthetic method, I can take these numbers here, 2, 13, and 20, and I could just, which is technically a 2x squared plus 13x plus 20, I can go ahead and do synthetic division again with the other 0 that's given, or the other factor that's given. 2 times negative 4 is negative 8. That gives me a 5. Negative 4 times 5 is negative 20. There's a 0. So I end up getting a 2x plus 5 here. That would be my final expression, the expression for depth. So what I'm showing you here is that you could do a different method on the last part. For number 4, you could say, let's do a factor box. I know the other factor is x plus 4, but I'm trying to figure out what this factor is. All right, or I could just do synthetic division again. So I could technically use synthetic division every single time to factor if I really like that method, rather than doing the box method to factor or anything like that. That's just something, some little trick to show you guys at the end here. But what really ends up happening with this problem with the box, we'll sketch it here. We end up saying that the depth is 2x plus 5. And then the front of the box was a length of x plus 4. And then the height was x plus 2. So that's what's happening with this box here. So if you multiplied all of those together, length times width times height, you'd get the standard form for the volume. That's why there's a volume versus the factored form, which would be length times width times height is another way to represent the volume of that box. Hopefully that makes sense. Okay, volume equals length times width times height. Okay. All right, so that covers everything for today. Let's talk about the assignment.